in calculus, we start using derivatives to analyze functions. So this first derivative test is going to look at the first derivative of a function. And from the first derivative test, you can determine when a function is increasing, when a function is decreasing, and you can also locate the extrema, the relative minimum and the relative maximum. So when a function is increasing, a tangent line is going to have a positive slope. So anywhere a function is increasing. So if I were to draw a function on here, let's look at a function. Let's just look at a parabola. If I were to draw a tangent line anywhere along here, that derivative is positive. The slope of that tangent line is positive. So this is when the function is increasing. Here at the very top, the tangent line has a slope of 0. And as you work your way back down, if I draw a tangent line along here, anywhere there, my derivative is negative. So my slope is negative. So that's what this is saying. So increasing function is when the derivative is greater than 0. Decreasing function is when the derivative is less than 0. In this case, we had a relative maximum. So the relative maximum occurs when the derivative is 0, but the derivative changes from positive to negative. If I were to continue this function, and right down here I have a derivative that's 0. So that means the derivative is changing from negative to positive. That would be my relative minimum. So I'll show you how that works through an example. So here's a polynomial. The nice thing about polynomials is they are continuous and differentiable over the whole over their whole domain, all real numbers. So that makes these very easy to work with. So the first thing I have to do is locate my critical numbers. To do that, I'm going to find my derivative and set my derivative equal to 0. So f prime of x equals 6x squared minus 6x minus 36. Set that equal to 0. I'm going to factor out the common term first. I can factor this x squared minus x minus 6. So I have 6, x minus 3, x plus 2 equals 0. So my critical numbers are going to be x equals 3 and x equals negative 2. That means something is changing or possibly changing at those two numbers. So these are my critical numbers. Sometimes you'll see them as c equals. It doesn't matter. That's where something is happening, something critical is going on. So the next thing I want to do is determine intervals, use appropriate test values, and assign the test value using a number line. So on my number line, I'm going to put my critical number. So negative 2 is about here and 3 is about there. I don't have to have any other numbers. I really am just happening what's happening before you get to negative 2, between negative 2 and 3, and after 3. Because I know the derivative is going to be 0 at these places. So I'm going to use this derivative, f prime of x, and figure out what's going on. I know f prime of negative 2 is equal to 0. I know f prime of 3 is equal to 0. That's what the critical numbers mean. So I want to find a number before negative 2. And I'll show you here, but in the process you don't have to show what you've plugged in. So if I plug a number left of negative 2, I can choose negative 3. So I'd have f prime of negative 3 is equal to, the 6 doesn't make a difference, so I don't need it, negative 3 squared minus negative 3 minus 6. So I have 9 plus 3 is 12. 12 minus 6 is 6. I just need to know that this is positive. It's hard to see that. Let me write that. That's positive. Then I need to pick a number between negative 2 and 3. I'm going to pick 0. So I'm going to do f prime of 0. So I get 0 squared minus 0 minus 6. 0 minus 0 is 0. 0 minus 6 is negative 6. So that means I'm going to get a negative number here. Then I have to choose a number greater than 3. Let's choose 4. So I want f prime of 4. So I'm going to have 4 squared minus 4 minus 6. 16 minus 4 is 12. 12 minus 6 is positive 6. So I know that this is going to be positive here. So that means anywhere that the derivative is positive, the function is increasing. Anywhere the derivative is negative, the function is decreasing. That's what I meant by up here. If f prime of x is greater than 0, then the function is increasing. If f prime of x is less than 0, then the function is decreasing. So I can state the function is increasing over the intervals from negative infinity to negative 2 and 3 to infinity, because f prime of x is greater than 0. This because is extremely important in AP Calculus. Now, when you watch the AP videos, they're going to tell you, they're going to go over a closed interval, and I'm fine with that either way. I've just always stressed that at the end of an interval, it's neither increasing or decreasing, so I'm not going to worry whether you use open or closed. I also know this is increasing, this was increasing. Here, the derivative is negative between negative 2 and 3, so I'm going to say the function is decreasing over the interval negative 2 to 3 because, and this because is important, f prime of x is less than 0. Now let's look at the other part of the first derivative test. We're going to look at the extrema. The extrema are the relative maximums and minimum values. Well, if you think of it this way, if a function is increasing, it's going up, then it levels out, it starts to go down, it levels out at 0, and it starts to go up again. It's a little bit easier to see. So right here, that's going to be a minimum. Right here is going to be a maximum. So to get my extrema, I would say at x equals negative 2, a relative max occurs because, now here's that word because again, f prime of x equals 0, and f prime of x changes from positive to negative. Sometimes they actually ask you for the point. If you want to know the point, you would find f of negative 2. So f of negative 2 would be, if I look back at this equation here, 2, negative 2 cubed minus 3 times negative 2 squared minus 36 times negative 2 plus 14. So the point would be negative 258. Sometimes they just ask you where it occurs. It occurs at negative 2. If they ask you for the maximum, it would be the point negative 258. Also here, this is another extrema. This was the relative minimum. So at x equals 3, and I already figured the point out. The point is 3 negative 67. A relative minimum occurs because f prime of x equals 0 and f prime of x changes from negative to positive. And that's what we were stating up here. A relative minimum occurs if f prime of x changes from negative to positive. And if it changes from negative to positive, it has to be 0 in between.